One more type of authorization that we need to talk about is resource-based authorization. So let me first show you what it is. I will open up the API project and navigate to the bookings controller. Let's focus on the get booking endpoint. So this is the endpoint where we can get an individual booking based on the bookings identifier. We're going to instantiate a query instance, send this query, and get a response back. The controller itself is already authorized, so only authenticated users can access this controller's endpoints. However, if we navigate to the get booking query handler, which is in the application layer, you will notice that there is a slight problem here. The query handler is using the SQL connection factory to create a database connection, is then executing this query using Dapper and returning the booking response. Inside of the query, we're making sure that this is the booking we're looking for in the where statement. However, there's nothing making sure that the user who is accessing this booking is the user that actually created the booking. Let me show you a practical example of how this is a problem. Let's start by authenticating with our API. We're going to get back an access token, and now I want to use this access token to get the information for the currently authenticated user. Notice the user ID that we get back, which belongs to the user with this email. Now I'm going to try to get a booking that I already created using this same access token. And you can see that we get the booking back, and the user identifier specified here matches the user identifier of the currently authenticated user. Now I'm going to do something different. Let's replace this email with a different one belonging to another user in the system. And now I'm going to use the access token of that user to try to obtain the booking. So I'm replacing the access token, sending the request, and we get back the booking for the user who did not create it. And this is a big problem in our API security. Granted, somebody would need to know the exact identifier of the booking, and because we are using GUIDs, there's a relatively low chance of this happening. However, this is still a security flaw in your API and you should fix it. And this is where resource-based authorization comes in. What we need to do inside of our get booking query handler is to make sure that the user ID of the booking response matches the user ID of the current user. I'm going to navigate to my user context abstraction, which contains some information for the current user. And let's expose another property here that we're going to call the user ID. We of course need to implement this in the user context class. So let's add another property, and I'm going to copy the implementation that I already have. However, this implementation returns a string. So I'm going to create another extension method to get the user ID from the current claims principal. So if I navigate to my get identity ID method, this is an extension method on the claims principal object. So let's create another one to fetch the user identifier. So let me make some adjustments here. I want to call this the get user ID method. It's going to return a GUID instead of a string, and I need to change the claim that I'm looking for. So instead of the name identifier, I need to be looking for JWT registered claim names, and I want to access the subclaim. Let's move the value of this claim into a variable that I will call the user ID, and this will be a string value. Now I need to make sure to parse my string value, so I will call GUID try parse. We're going to pass the user ID string, and we're going to get back a parsed value, which I will call the parsed user ID. And then if my try parse method returns true, I'm going to return the parsed user ID from this method. Otherwise, we're going to throw an exception. And let's also update the message here to say user identifier is unavailable. So if I go back to my user context, you will see that my implementation is now correct. And let's go back to the get booking query handler and make our adjustment. What I'm going to do is add an if statement here, and I will say if the booking is null, or if the booking user ID does not match the ID of the current user. Now, how do we know who is the current user? Well, we're going to use the iUserContext service. So let's inject this user context in our query handler, and now we can use it inside of the handle method to implement our resource-based authorization check. So I just have to say user context and specify the user ID, and if this evaluates to true, then I'm going to return a failure result from my query handler. So this will be a failure result of a booking response, and I can specify a booking errors not found as my error value. So you can see how resource-based authorization is really important in your APIs. You might be tempted to implement a generic solution for this, and this is definitely possible and even required in some applications, but in our context, I think this is satisfactory. So let's actually test this implementation and see if it did what we wanted it to do. I am still authenticated as the user who should not have access to this booking. So let's send this request again, and we hit the breakpoint inside of the get booking query handler. So if I check the user ID on my booking response, you will see one value, but if I access the user ID on the user context, you will see a different value, which is why we're going to return a failure result and a 404 not found response from our API. However, if I log in as the user who should have access, so let me update the credentials. I'm going to get a new JSON Web Token, and let's use this JSON Web Token here and send this request again. This time the user ID on the booking and the one on the user context will match, and we're going to return the booking from our API. So you can see that we get the response back in Postman, and we have successfully implemented resource-based authorization. In this chapter, you'll learn how to implement authorization in your APIs and significantly improve the security of your application. We discussed 3 different kinds of authorization policies: role-based authorization, permission-based authorization, and resource-based authorization. I showed you how to implement all 3 of these authorization approaches, what are their pros and cons, and what are some improvement points that we're going to make in the following chapters. So let's see what's next in store in the Pragmatic Clean Architecture course.